Hello everybody and welcome back. So we talked a little bit about trig ratios, and now what we're going to take a look at is a few different situations where we would use these trig ratios. Because otherwise, if we're not going to use them somewhere, why bother learning it? What's the important part of it? So here's a few places where we need to use trig. Here I've got a right triangle, and I'm given two sides. I am given that this side here is 12, and I'm given that this side here is 15. And we're trying to find angle D. Now, nothing we have up to this point other than trig would allow me to find measured angle D. I could use Pythagorean theorem to maybe find the length of DE, but I can't use it to find an angle measurement. So this is going to be one of the places where I use trig. And remember, our three trig ratios are sine, cosine, and tangent. Sine is the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. Tangent is the opposite over adjacent. Now you will need to remember which of those are which. We will get to a point where you need to know those ratios. But for now, I'll have a little sheet up there so we can do this together, and we can reference that sheet as we need. So let's take a look here. Angle D, it's the one I'm looking for, so that's going to be my reference angle. And according to angle D, I need to look at which two sides I have. I have 12. According to D, which side is 12? Did you say the opposite side? You would be correct. 12 is the opposite side to D. And what about 15? 15 is the adjacent side. It's right next to D. And it's not the hypotenuse. Again, it's the one that's next to D that's not the hypotenuse. So I need to figure out which of my ratios uses the opposite side and the adjacent side. And if you look over here, you'll notice it is the tangent ratio. The tangent ratio is the opposite side over the adjacent side. So that's what I need to set up. Again, my reference angle is D, so I'm going to set up tangent of D equals opposite, the opposite side is 12, over the adjacent side, which is 15. And now I want to find what the angle measurement is that matches that. This is going to be where I'm going to want to convert 12 15ths probably into a decimal. If I'm going to use the chart, I'm going to want to divide those two. I can certainly reduce. I can divide 3 out of both and get 4/5. But I really want that as a decimal. So I'm going to say tangent of angle D equals 0.8. That would be 4/5 as a decimal. You can divide 4 by 5 if you're not sure exactly what that is. But our tangent of D is 0.8. So what I need to do now is figure out what angle has a tangent that's about 0.8. This is where we turn to our handy-dandy trig chart. Because our chart has all the tangents. So if I look at this chart, here's every single tangent for every single whole angle measurement. My tangent column starts here, goes all the way down, and then wraps around over here for the other half of the angle measurements. I want to find the closest thing to 0.8. And if we look, this is going to be the closest value we have. 0.8098. That's really close to 0.8. And what angle measurement does that match? It matches 39 degrees. So I know that the angle whose tangent is closest to 0.8 is 39 degrees. That's going to allow me to say that angle D is approximately 39 degrees. Okay? Look all right? All right, what I'd like you to do is try to find angle E now. So let's say we're looking for angle E. Use that as your reference angle. And again, use 12 and 15. Set up your ratios. And I want you to pause it right now and try to find angle E using a trig ratio, just like we did a minute ago. Now, I know there's an easier way to do it, and we'll look at that too. But for now, try to find angle E. So pause it and go ahead and do that right now. Did you find it? Did you set up your ratio? Okay, let's take a look. Again, the two sides I have are the opposite side. This time 15 is the opposite, and the adjacent is 12. So I again need the one that uses opposite and adjacent, which is again tangent. So it's tangent, this time of angle E, equals opposite side, which is 15, over the adjacent side, which is 12. Again, I can reduce this to 5 over 4, which is 1 1/4. I want it as a decimal, so we'll say tangent of angle E is 1.25. And now I want to go back to my trig chart and figure out which angle has a tangent about 1.25. So I'm going to go back to our chart here. This time I don't want 39. I want the one that's closest to 1.25. If I look at my tangents, it's between these two. I got 1.2349 and 1.2799. Which is it closer to? It's a little closer to 1.2349, and that matches 51 degrees. Okay? If you said either 51 or 52, I'd probably take either, but it's a little closer to 51, or you could even say 51.5 maybe. So we're going to go back and say angle E is approximately 51 degrees. Okay? Now some of you may have been shouting at the screen, there's an easier way to do it, Mr. Doran. There's an easier way to do it. And you're correct. So let's take a look at that map. If we just found angle D, and angle D was 39 degrees, that means this is 39. And since this is a right triangle and this angle is 90, what do all the angles in a triangle add up to? They all add up to 180. If my right angle is 90, that means that angle E and angle D have to add up to 90 as well. So if I know angle B is 39, all I need to do is do 90 minus 39, and I get 51 degrees. That would be the easiest way to find angle E once I've found D. I don't need to set up the trig ratios, but it was good practice, wasn't it? I think so. So that's how to find angle measurements using trig ratios. And now I want to take a look at finding side measurements using trig ratios. So now we've got triangle ABC, and this time I have angle ABC right over here. This angle is 20 degrees, and I have that the hypotenuse is 32. I'm looking for x and y. Now, I can't use Pythagorean theorem at all on this one, because I only have one of the three sides. In Pythagorean theorem, I need two of the sides, right? This is where trig comes into play. Trig will allow me to find these two sides even though I only have the hypotenuse, because I also have an angle measurement. So, here's what we're going to do. Let's find angle x, let's find side x first. Now, if 20 is my reference angle, here it is, which side is x? Did you say the adjacent? If you did, you're wrong. It's the opposite side. It's across from it. So x is the opposite side, and 32 is what? 32 is the hypotenuse. Okay? So, again, I need to remember which trig ratio uses the opposite side and the hypotenuse side. If you don't remember, we'll look over here. It's the sine ratio. So I want to set up the sine of my angle, which is angle B, but I know the measurement. So I'm going to say the sine of 20 degrees, because I know angle B is 20. So the sine of 20 degrees equals the opposite side, x, over the hypotenuse, 32. Now I've got that equation set up. Now it looks like I have two unknowns. I have x and I have sine of 20. But while I don't know sine of 20 off the top of my head, and I'm guessing you probably don't, guess what does? Our handy-dandy trig chart. So I want to find the sine of 20. Let's look at our chart. Sine of 20. Well, here's the sine column. And I want to look down until I get to angle 20. Here's angle 20. The sine of angle 20 is 0.3420. 0.3420. So I can now replace sine of 20 with 0.3420. Let's do that. So sine of 20 is 0.342 equals x over 32. Now I can solve for x. Do you remember how to solve things that look like this? One way to do this, and what might help you, might remember, is if I put this over 1. If I do that, what kind of equation is this? This is a proportion. And remember, to solve a proportion, we cross multiply, right? So I'm going to cross multiply here. X times 1 is x. And then the other value I want to do is 32 times 0.342. Now, I don't know if that off the top of my head. Maybe you do. If you do, impressive. I'm going to multiply by my calculator here. 0.342 times 32. And I get 10.944. Hopefully you got the same. Nearest 10, we'll say 10.9. That's our value for x. Look okay? You follow how to do that? Again, rewind if you didn't quite follow that. Now what I'd like you to do is on your own, I want you to try to find side y. Again, using trig ratios. Again, using their side measurement and our angle B, which is 20. So go ahead and pause, try to find y. Okay, I'm going to assume you're back. I'm going to assume you've tried to find y, did you? Did you find what it is? Let's take a look. So, this time, I'm looking for y, which according to B is the, which side? Adjacent side. And 32 is still my hypotenuse, still across from the right angle. So I need to figure out which trig ratio uses the adjacent and the hypotenuse, and if we look over in our chart there, it is the cosine. So I want to set up cosine of 20 degrees, that's our angle measurement, cosine of 20 equals adjacent, which is y, over the hypotenuse, 32. Okay? Now, again, I don't know the cosine of 20, and I'm betting you probably don't either, but our trig table does. So I'm going to look here. This time I don't want the sine, this time I want the cosine. And our cosine is 0.9397. And again, I don't want sine, I want cosine. So 0.9397. We can now replace cosine of 20 with 0.9397. And I'm repeating that a bunch of times so I will remember. So this is 0.9397. Did I remember that correctly? I hope. Otherwise, I'm going to get it wrong. So we replace cosine of 20 with 0.9397. And now we can set up a proportion and cross multiply to solve for y. So here we go. Y times 1 is y equals 0.32 times 0.9397. Again, I can't really do that in my head, so I'm going to type it in here. 9397. And I want to multiply that by 32. And we get 30.0704. Nearest tenth, we'll say 30.1. That's our value for y. Hopefully that's what you got. Did you get it right? Excellent. All right. At this point, if you've had enough practice, if you followed those examples and they've made perfect sense to you, you can go ahead and stop the video now. If you want a little bit more practice or you think it might be helpful to go through a couple more, I'm going to go through a couple more examples. Okay? So let's go to the next page. So here we have a triangle STU, and I want to find the sine, the cosine, and the tangent of angle S. Now each of those are ratios, right? And again, we do need to start to remember which of those are which. The sine ratio is the opposite side over the hypotenuse. So if I want to find the sine of S, we're going to do the opposite over the hypotenuse. The opposite side, here's my reference angle. Opposite is 14. The hypotenuse across from the right angle is 50. Now all I'm looking for, sine of angle S, is a ratio. That is my ratio. Good to put it in the simplest form, so I do want to reduce it. I can divide 2 out of both to give me 7 over 25. You can certainly convert it to decimal if you'd like to, but simplest form fraction is probably one of the best ways to leave it for now. Okay? Now, what I'd like you to do, try to find the rest on your own. Let's try to find the cosine, tangent, and if you know how to find the angles, like we just did a minute ago, try to find those. So pause it, go ahead and try to find those. Okay, let's take a look at how to find each of these together. Cosine of angle S. Cosine is the adjacent over the hypotenuse. The adjacent side is 48. Here's angle S. Here's the adjacent side, 48. So it's 48 over the hypotenuse, which is 50. Again, I want to reduce that. 2 comes out of both. That would be 24 over 25. Again, put it as a decimal if you want to, but simplest form fraction is a good form to leave it in. Tangent of S. Tangent of S, remember, is the opposite over the adjacent. Opposite is 14. The adjacent side was 48. And I'm going to divide 2 out of both again and get 7 over 24. Now I have all 3 trig ratios for angle S. Angle S was my reference angle. Those are my 3 ratios. Now if I want to find the measure of angle S, here's the cool thing. I can use any of those trig ratios. We found all 3 of them, right? So pick one. You pick your favorite one. I'm going to pick one. You can do a different one for me, or you can do the same one for me. Up to you. I'm going to go with the sine of S equals 7/25. I'm going to use that to find the angle measure. So I know the sine of S is 7 over 25. I'm going to want that as a decimal so I can look it up in my chart. So 7 divided by 25 gives me 0.28. I want to look at my chart and find the angle whose sine closest matches to 0.28. So I'm going to look at our chart here. In my sine column, here's my sine column, I want to try to find 0.28. So let's see, I scroll down here. Looks like that's pretty close. 0.2756 is really close to 0.28. So I'm going to say that our closest angle is 16 degrees. And I can come back and pretty confidently say angle S is about 16 degrees. Not too bad, right? If you use cosine or tangent, did you get the same thing? I hope so. You might have gotten very, very close, but you should still get 16. Now, once I have that, how do I find angle T? I could use trig again. I could find one of the trig ratios for T. But again, S and T have to add up to 90 because it's a right triangle and U is already 90 degrees. So once I know that, 90 minus 16 should give me 74 degrees. That's my measurement for angle T. Look good? Sound all right? Okay. Let's do another with sides. So now I have triangle PQR, and I want to find the measure of x and y. I'm given an angle measurement, which is good because I need an angle measurement, and my angle measurement for Q is 50 degrees. So that's going to serve as my reference angle. Why? Well, because they gave me that one. Could I use R? Sure, we could use R if you want to. We could find R. R, of course, would be 90 minus 50, which would give you 40 degrees. We could use that. But I was given Q, I may as well use it. And I'm going to try to find x first. X is across from the right angle, correct? Which means which side is x? X is the hypotenuse. And 20 is the side that's right next to it. That's not the hypotenuse. So 20 is the adjacent side. And again, we need to remember which ratio uses the adjacent and the hypotenuse. It is the cosine ratio. So I want to set up cosine of 50 degrees equals the adjacent side over the hypotenuse, 20 over x. Okay? Now, again, I don't know what the cosine of 50 is, but my trig chart does. So I go over to the trig chart, and here is 50 degrees, and here is the cosine of 50 degrees. Cosine of 50 is 0.6428. Cosine of 50 is 0.6428. We can now replace that. 0.6428. That's equivalent to cosine of 50. And now I can bring the rest down. Equals 20 over x. This time x is on bottom, right? I'm still going to solve this by cross multiplying. I'm just going to take one extra step. So we cross multiply here. We get 0.6428x equals 1 times 20 is 20. And now what I need to do to solve for x is divide both sides by 0.6428. And I have no idea what that is off the top of my head, so I'm going to have to do it. 20 divided by 0.6428 on the calculator gives us x equals 31.1. That is the length for x. And it's 0.113872, blah, blah, blah. So that should be our value. What I'd like you to do is find x. So pause it and find x. I'm sorry, we've just found x. Pause it and find y. Okay, I'm going to assume that you found y, and we'll see if what you got is correct. So this time, I want to find y. Y, according to my reference angle, is the opposite side, right? And I'm going to once again use 20, which is the adjacent side. And again, I need to remember which trig ratio uses the opposite and adjacent. Hopefully you've done these enough times that you're starting to remember opposite and adjacent is tangent. So I want to set up the tangent of, what's my angle? 50 degrees equals the opposite y over the adjacent 20. And again, I don't know what the tangent of 50 is, but my table does. 50 degrees. Tangent this time is 1.1918. 1.1918. So let's replace that. 1.1918 y over 20. And now I want to cross multiply. So here I get y equals 20 times 1.1918. 1.1918 times 20 gives us 23.8. And it's 0.836, so nearest tenth, 23.8. That's our value for y. Is that what you got? Hopefully it is. And if you look at the sides, they look about right. That's the smaller side, 23.8 and 31.1. Hopefully those examples made a little bit of sense. If you need to go back and watch them again, you are welcome to do so. And I hope you learned a little bit from that. See you next time.